In this video, we will review the proper termination procedure of a System 1850 Single Conductor Copper Sheathed MI power cable using our sized-up Quickterm kit. Copper-sheathed MI power cables are classified by UL and ULC as 2-hour fire-resistive, and the improper termination of the cable can jeopardize its integrity and reliability. Before we begin, let's double-check that your Quickterm kit contains all the necessary items you will need in order to terminate the cable correctly. Inside your kit you should find 2 heat-shrinkable tubes, 2 brass gland connectors, 2 copper compression connectors, 1 or 2 rolls of self-amalgamating tape, 1 roll of emery paper, and 1 green card. Also make sure that you have all the tools required to perform the termination. A PYROTENAX Sheathmaster tool for stripping MI cables up to 3/4 inches in diameter, or a ratchet Sheathmaster stripping tool for cables larger than 3/4 of an inch in diameter, and a PYROTENAX hand vise. In addition, check that you also have the following set of standard tools in your kit. Do not proceed until you do. Review the installation instruction manual supplied with the termination kit to understand how the termination is made and to determine the size of stranded wire tail required for the MI cable being terminated. Prepare your transition enclosure by installing a brass plate. Electrical codes require that precautions be taken to prevent heating by induction when single conductor cables enter a ferrous metal enclosure. This is done by cutting out a section of the steel enclosure and replacing it with a 1/4 inch, 6.4 mm thick brass non-ferrous plate available from nVent.com/PYROTENAX at each end of the cable run. The NEC requires a brass plate for all single conductor cables. In Canada, the CEC requires the brass plate only when conductor current exceeds 200 amps. Refer to the Installation Instruction Manual H57864, supplied with the MI cables for more details. Depending on your situation, the cable may be terminated before or after connecting the gland connector to the enclosure. We will terminate the cable before the gland is connected to the enclosure with a hacksaw and using the hand vise to hold the cable in place if needed. Cut the end of the MI cable square and file the end smooth using a flat file. The gland connector is an assembly which consists of 3 parts: the gland nut, the compression sleeve, and the gland body. Now, making sure the 3 pieces of the assembly are in the correct order, slide the brass gland connector assembly over the cable sheath and place a small piece of tape on the cable if needed to keep the gland assembly from sliding back down. Identify the compression connector supplied with the termination kit and locate the corresponding compression connector part number in the table on page 3 of your installation instruction manual. Mark the MI cable sheath at the length specified in the table, as this will be the length of sheath to be removed. If using the Sheathmaster sheath stripping tool, place a second mark 1 inch, 2.5 centimeters behind the first mark. If using the ratchet stripping tool, place the second mark 1.5 inches, 3.8 centimeters behind the first mark. The sheath will be stripped back to the first mark, exposing the solid conductor. The second mark is only used to position the hand vise for final stripping. Next, strip the copper sheath off the MI cable. Grip the cable with the hand vise and begin stripping the copper sheath back towards the first mark. Note that the Sheathmaster stripping tool must be adjusted depending on the cable size diameter being used. For detailed instructions on how to operate the Sheathmaster stripping tool or the ratchet stripping tool, please refer to the instruction manual that came with the tool, or download a copy from nVent.com/PYROTENAX. Continue to strip the copper sheath, adjusting the grip on the hand vise as you move up the cable to keep it from turning. For final stripping, grip the cable with the hand vise at the second mark, and when the stripping tool touches the edge, it will stop and make a clean cut on the cable sheath at the first mark, exposing the correct length of solid conductor. Ensure that the sheath is not beveled inward. If it is, Strip back an additional 1/4 inch, 6 mm of cable sheath. Clean the exposed conductor with a clean, dry rag or cloth to remove all white magnesium oxide powder from the conductor. Polish all around the entire length of the solid conductor and 2 inches, 5.0 centimeters of sheath behind the conductor with emery paper to achieve a clean surface. Visually inspect the magnesium oxide insulation at the face of the cable for traces of copper filings and burrs. If present, you can remove them with a pick or gently tap them out. But do not blow them out, as this can introduce moisture to the end of the cable. When cleaning the conductors, be careful not to remove more powder from the face of the cable than is necessary. Now you must perform an IR test using a megameter set to 500 volts DC to check the insulation resistance of the cable between the conductor and the sheath to ensure that it is free of grounds and shorts. The other cable end must be terminated or sealed in order to perform the test, or a low IR reading will result. If unsure on how to perform a correct insulation resistance test using a megameter, please pause this video and watch our supporting video performing an IR test for detailed test procedures and IR test criteria. Note that low IR results indicate that moisture is present in the end of the cable and must be removed before continuing the termination. When IR readings are satisfactory, immediately terminate the end of the MI cable, or a delay can cause the IR to drop and the cable must be retested prior to terminating the end. Now continue the termination by applying a tape seal to the MI cable. Refer to the instructions manual to find out the correct taping area required for your MI cable size, and place a mark on the sheath accordingly. Stretch the sealing tape just short of the breaking point, or to about half its original width, and avoid making contact with your fingers. Remember to only use the self-amalgamating tape supplied by nVent PYROTENAX. Then, beginning on the cable sheath and using half laps, wind the tape under the tension taping 1.5 inches to 1 3/4 inches, 3.8 centimeters to 4.5 centimeters along the cable sheath, and 1.5 inches to 1 3/4 inches along the solid conductor. Reverse the direction and wind the tape back along the conductor to the sheath. Finally, reverse the direction once again to tape along the sheath to the conductor, maintaining half laps and stretching the tape. When finished, tear off the excess tape, and in a short time the tape will bond to itself. Once the tape seal is completed, the end of the MI cable should appear this way. Now, feed the MI cable through one of the holes in the brass plate and into the enclosure. Screw the gland connector into the threads in the brass plate and tighten the threaded section of the gland assembly into the plate. Finally, tighten the back section of the gland assembly to the MI cable so that it is secured to the enclosure. Next, install the heat-shrinkable tubing supplied with the Quickterm Kit over the MI cable. Now, you will want to identify the compression connector. The solid MI cable is inserted into the smaller end of the connector, with the copper reducer sleeve, and the stranded conductor tail must be inserted into the larger end. Strip just enough insulation from the appropriate AWG size 90°C 600-volt stranded conductor tail to fit into the center stop in the compression connector. Crimp the connector to the stranded conductor tail using the required number of crimps and an approved crimping tool. See table on page 3 of your Quickterm instruction manual for the complete guidelines regarding size of conductor tail, approved crimp tools, and number of crimps needed for your specific termination. Note that where multiple crimps are required, the outside crimp needs to be made first and then work towards the middle of the compression connector. Crimp the connector to the solid conductor, again, making the outside crimp first and working towards the middle of the connector where multiple crimps are required. Remove all sharp edges from the compression connector with a flat file. Now, place the heat-shrinkable tubing over the joint so that it completely covers the tape seal and compression connector, and overlaps the MI cable sheath and the insulation on the stranded connector tail by at least 1/2 inch, 1.3 centimeters. Shrink in place with a heat gun or propane torch, being careful not to burn or damage the heat-shrinkable tubing. Finally, you need to perform another insulation resistance test to check the IR from the stranded conductor tail to the MI cable sheath to ensure that the cable has been properly sealed and the IR is satisfactory. Again, if unsure on how to perform an IR test, watch our supporting video, Performing an IR Test. This now completes the installation of System 1850 single conductor copper-sheathed MI power cables using the Quickterm Kit. You can use the same procedure to terminate all the remaining single conductor MI cables going into the enclosure and make all the final connections. For further assistance and product support, please contact nVent Support at 1-800-545-6258 or visit nvent.com/PYROTENAX.